So the next we'll be looking at is covalent bonding. So your equivalent bond and your covalent bond, they are the most common. This is where they bring most of your questions from JAM on chemical combination. So let's look at what an equivalent bond is. So from the word co, it's talking about sharing of your valence electrons. Sharing of your valence electrons. So this is the bond from sharing of valence electrons. So unlike your electrovalent bond, where you either lose or gain electron or electrons, here you share. That is what covalent bond is all about. And for covalent bond, we have two broad classes. They are either homonuclear, that is, they come from the same atoms are combining, or heteronuclear. So this one say same atoms for elements combined. Why this one is different atoms or elements combined. So what do we mean? Let's look at some example. For your homonuclear, we have your hydrogen gas. So initially we have your hydrogen gas, we have your chlorine gas, we have your oxygen gas, we have your fluorine gas, and the rest. While for your heteronuclear, we have your hydrogen fluoride. So you can see two different atoms or elements are combining. We have your CO2, we have your H2O, we have your ammonia. So all these are what are heteronuclear covalent bonds. So let's look at how they actually share electrons and the groups that are involved. So say for covalent bond, the groups involved in covalent bond are groups 5 to group 7. So groups 5, 6. So starting from groups 4. So groups 4, 5, 6, and 7. And there's what we call covalency. Covalency is the number of electrons that an atom of an element can share. Just where we have electrovalency, the number of electrons you gain or lose. While this one we have covalency. So your group 4 elements, they have a covalency of 4. That means they can share 4 electrons. So, and why is that? I will explain it quickly. Let's take, for example, your carbon. Carbon is 2, 4. This is your carbon. The atomic configuration is 2, 4. That means it has 4 valence electrons. So after you have filled your first 2 electrons here, you have 4 unpaired electrons. Take note of the word unpaired electrons. So you have 4 electrons. So it can share these 4. So what happens is that when it comes to covalency, the unpaired electrons want to be paired. That is the only way they can achieve their 8 outermost shell electrons. So because of this unpaired nature, it can combine, it can share these 4 electrons. So for example, let's say it's sharing with oxygen that just needs 2. So if you look at oxygen, your oxygen is what? The outermost shell is 6 electrons. So 1, 2, 3, 4, 5, 6. So it just has 2 unpaired. This one has 4 unpaired. So this one we need to pair with 2 different electrons. So one oxygen comes and take this, and this other free electron comes and pair with this. So here now we now have a what? This oxygen atom. Then another oxygen atom now comes and pair with this other 2 electrons. We now have what? Another oxygen atom. That is why we now have what? CO2. So 1 carbon and what? 2 oxygen. Do you understand? So I hope you do understand. Yes. So that is how the sharing of electrons happens. So let's quickly come back. Then we say group 5 has a covalency of 3. So they need 3 more electrons to pair. Why? For example, let's say nitrogen. Nitrogen is the 7th element, so we have 2, 5. That means it has 5 valence electrons. 1, 2, 3, 4, and 5. So you can see it requires 1, 2, 3 more. So you can share these 3 in order to complete the atomic shell. So group 6 will what? We require 2. So it has a covalency of 2. And group 7 has a covalency of 1. So hydrogen, and let me say hydrogen. So hydrogen also falls under here. It has a covalency of 1. So yes, this is how they form their bonds. So what happens when, let's look at let's go back, our homonuclear molecules. What happens if hydrogen, the hydrogen has 1 electron, is the first element, this hydrogen. Then another hydrogen comes with 1 electron. For them to look like helium and get a duplex state, that is, make their outermost electrons equal to, they will come and share these 2 electrons, and you now have something like this. 1, 2. So they are sharing those 2 electrons. So this one has 2 electrons, this one has 2 electrons by virtue of their sharing, and that's why we now say hydrogen 2. So their bond between them is what? A singular covalent bond. I see it. So that is it. And here's what we call their dot formula. This is the number of bonds 1, while this is the dot formula showing the electrons being shared. So take note of your dot formula. So I will say that let's look at another scenario. Let's say oxygen. Oxygen, we say, has 6 atomic electrons. So 1, 2, 3, 4, 5, 6. So these 2 are unpaired. So what happens when another oxygen comes with 6? 1, 2, 3, 4, 5, 6. So these 2 are unpaired. So what happens here? If these 2 now come here, let's say, remember that we said they are sharing. So if these 2, if this oxygen shares his outermost electrons, these 2 unpaired electrons with this one, what we now have? We now have 1, 2, 3, 4, 5, 6, 7, 8. So this one we have 8 electrons. This one shares with this one. This one also have 8 electrons in the outermost shell. That's why 2 oxygen will come together and now form oxygen 2. I see it. But remember, for this one, the bond between them is what? 2 covalent bond, because they are sharing 2 electrons. So this is the bond between them, and their dot formula will be what? Oxygen. They are sharing 4 electrons between them. So this will be their dot formula showing Okay, they have two electrons, two paired electrons and two unpaired electrons. So these are the electrons that they are sharing, these four, while these are the electrons that they have. So take notes. I hope that explains it. So this will be their dot formula. So that is it for hydrogen and oxygen for your homonuclear atoms. Now let's look at your heteronuclear atoms. For your heteronuclear atoms, let's say hydrogen and what? Sulfur. Okay, hydrogen. Yes, it's hydrogen and fluorine. So hydrogen has one electron, while fluorine, being a group 7 element, has 7 outermost electrons. So 1, 2, 3, 4, 5, 6, 7. So you can see they just need to share this one. So fluorine will become what? Will become 8 outermost, while hydrogen will become 2 outermost filled electrons. So what happens once they share? We now have what? Hydrogen fluoride, and the bond between them is what? Is a singular covalent bond. Singular covalent bond, and their dot formula will now become what? The sharing of the electron shared between their middle, their fluorine. Remember, fluorine already has paired electrons, so you write those paired electrons 1, 2, so 3 paired electrons. So that way, this is the dot formula of hydrogen fluoride. Do you understand? I can hear you say yes. So you should know that all the atomic molecules, all. So having said that, we're not looking at the shapes of these heteronuclear substances or the shape of covalent bond. That is a very common question they ask. So for our last part, we'll be looking at the shapes. So we're looking at the shapes of covalent bond. This is the most important from my assessment so far. The law bringing out the shapes of electrocovalent compounds. So we see all the atomic molecule are linear. That means they are straight. All the atomic molecules are linear in shape. So take note. That will mean that what? Your hydrogen fluoride is linear. Your hydrogen fluoride is linear in shape. Your hydrogen gas itself is linear in shape. Your chlorine is linear in shape. They are all diatomic. Then the next one you want to take note of. So when we say diatomic, they are made up of 2 atoms, hydrogen and fluorine, hydrogen, chlorine. Then the next one you want to take off is that CO2 is linear in shape. So CO2 is also linear in shape. Take note. CO2 is linear in shape. Then water, H2O, is V-shaped. H2O is V-shaped. Obviously it is what? Bent. Why? Let's look at H2O. For hydrogen bond, this is what you get. You have your 1 hydrogen, 2 hydrogen and what? 1 oxygen. So you can see this is what's like a V. I see it. A right-sided or left-sided V, anyone. So H2 is what? V-shaped. So when you think of H2, think about this bond that is formed there. Then another one is your ammonia. NH3 is your ammonia. How is ammonia formed? I don't want to go through the details, but now nitrogen has what? Is a group 7 element, so it has 3 covalency. That's what we saw, since it's group 7. So it's group 5. So this is your nitrogen. Or let's see, this is your nitrogen. It has 5 valence electrons. So 4, 5. So it has 3 more. So 1 hydrogen will come here and pair with it and bring this electron. We have 1 hydrogen. Another hydrogen will come here and pair with it, bringing it one electron, and another hydrogen come here and pair with it, bringing it one electron. So now what? NH3. That is how we get our NH3. So the dot formula is that we now have this. So if you look at the structure of ammonia, you see something like this with its this electrons here is representing this one that it has already paired. Then the other ones are the ones formed with what? Formed with hydrogen. So we have one bond here, we have another bond here, and we have another bond here. Let's see. So if you look at this clearly, it's looking like a pyramid. And what is a pyramid? A pyramid is something like this. You know the Egyptian pyramid. What comes to mind? Something triangular. I see it. So let's say it has 3 bases, then they all go to one point. I see it. So I don't have to really get you to picture it, but this is a pyramid. This is a pyramid where this is your peak. Are you seeing? So this is your nitrogen right here, while these 3 points, 1, 2, 3, they are your hydrogen. So that's why we say ammonia is pyramidal in shape. Pyramidal in shape. Ammonia is pyramidal in shape. I hope I explained it well. So we have 3 points. This is your hydrogen, this is your hydrogen, and this is your hydrogen. 3 hydrogen. I would say nitrogen at the center. So pyramidal is these 3 connecting like this. And if you check, this is how a pyramid looks like. I see it. So yes, that is a pyramid. Then the last one that we'll be looking at is your methane. Your methane is CH4. Remember that carbon is the 4th group, so it has 4. Its covalency is 4. That means it has 4 electrons to be shared. So if it shares those 4 electrons, it will be in a tetrahedral shape. Tetrahedral. Tetra means 4. So tetrahedral shape. Take notes. Tetra here means 4. So anytime you think of tetra, that means one of these atoms should be 4. Pyramidal, one of them should be what? 3. Then linear, we say all the atomic. Then CO2 is also linear in shape. So these are the shapes that you want to know. Then before we finish for today, we want to know the characteristics of covalent compounds. What are their characteristics? So lastly, before we look at the coordinate covalent bond and the metallic bond, in our next class, let's just look at the characteristics of covalent compounds. So number 1, we say covalent compounds exist as gases. So they exist majorly as what? Exist as gases. So hydrogen gas, chlorine gas, your hydrogen fluoride, CO2, oxygen gas. So they exist as what? Gases. Then they are non-conductors. Non-conductors of heat and electricity. Non-conductors of heat and electricity. So even if they never have a molten state, unlike your covalent bond that we saw that can conduct electricity in molten states, then they don't form electrons. So let's say electrons, they don't form ions, so they can't conduct electricity even in molten states. Next, we say they are insoluble in water. That is, they cannot dissolve in water, unlike your electrovalent compounds that can dissolve in water. But these guys, they are soluble in organic solvents. So they are soluble in organic or non-polar solvents. So you'll be hearing the word polar and non-polar a lot. Let me just explain. When we say something is polar, polar means pole. Polar means pole. And you know a pole has what? 2 ends. So polar, that means there is a positive end and there is a negative end. For example, the poles of the earth are north and south. So there are 2 ends to a thing. So when we say a substance is polar, that means it has 2 poles, positive and negative. So your water is a polar solvent because it dissolves polar substances and they form ions in it. So these guys, they cannot form ions. So if you put them in water, they cannot dissolve. They are non-polar. They don't have poles. You can see that they are sharing electrons. We would not say that they are positively. We would not say positive charge comes to negative charge. Those are two different poles. These guys don't have poles, so they are non-polar. Same thing with the organic solvents. They are non-polar because they don't form charges. They don't have poles. I hope this explains it. And so basically that is it for your covalent compounds. Please, let's go over everything that we have discussed today. So we started by saying chemical combination can be intermolecular, that is between the atoms of a molecule, and it can be intermolecular, that is between the molecules themselves. And for intermolecular, we said we have the ionic, which we have discussed, the covalent, which has to do with sharing, the coordinate covalent, we'll look at it later, the metallic. Then for the intermolecular, we see hydrogen, van der Waals, and dipolar forces. Then we went on to talk about the ionic or the covalent bond, which has to do with what? Bond between ions. And what do you say ions are? Ions are charged particles formed when an atom loses or gains an electron. And what are types of ions? We have the cations and the what? Anions. We say the cations are positively charged. They are formed by losing electrons, and they move towards the cathode of an electrolyte. And next, we say for your anions, they are negatively charged. They are formed by the gaining electrons, and they move towards the anode. That is why they are called anions, anode ions. We say the guys that form your cations, they are your group 1, group 2, and group 3 elements. So from group 1 to group 3, they form your cations, positively charged. While your group 5, group 6, and group 7, they form your anions, which are negatively charged. So we look at the formation of ionic compounds, and we say ionic compounds are formed by combining the ions in inverse proportion of their charges. So we looked at the combination of sodium and chlorine, sodium and sulfur, and aluminium and sulfur. Then lastly, for that, we look at various combinations from group 1 to group 3 against group 5 to group 7, and I told you to complete this table. Then next, we look at the characteristics of ionic compounds. We say they have high melting and boiling point because of their strong electrostatic force. Then they do not conduct electricity in solid states, which is the state in which they exist majorly. Then number 3, we say they conduct electricity in molten states or when they are in solution. Then next, we say they are insoluble in organic solvents, just to add, but are soluble in water. So they are soluble in water. Then lastly, we say they mostly exist as solids. Then we now look at covalent bond, where we say this is the bond from sharing of valence electrons. Take note, in this sharing of electrons, both atoms bring the electrons. So let's say in which electrons are contributed by both atoms. In which electrons are contributed by both atoms. So the atoms involved, they all bring electrons, unlike what we'll be seeing in coordinate covalent bonds. Then we said for a covalent bond, you have your homonuclear and heteronuclear. Homo means same, while hetero means different. So homonuclear, same atoms or same elements, while these are heteronuclear, different atoms are involved. Example of homonuclear, we have your hydrogen gas, chlorine gas, oxygen gas, fluorine gas. And for your hetero, we have hydrogen fluoride, we have your CO2, your H2O, your ammonia. Then look at the groups involved in forming covalent bonds. We said your group 4 to group 7, and they have what we call covalency. The covalency of group 4 was 4. The covalency of group 5 elements is 3. The covalency of group 6 elements is 2. And the covalency of group 7 elements is 1. And we said this covalency is due to the number of unpaired electrons. So you can see nitrogen that is in group 5 has 3 unpaired electrons, and those are available for sharing, and that is why it has a what? A covalency of 3. So next we look at the shapes of covalent compounds. We said all the atomic molecules are linear in shape. We said CO2 is also linear in shape. Hydrogen, that is H2O water, is V-shaped. Take note, Jean love asking these questions. Then we said ammonia is pyramidal. I told you that once you see H3, a molecule that has 3 against 1 with just 1, you should be thinking of pyramidal shape, and I explained that using a pyramid. Then we look at methane. Methane is tetrahedral in shape, and I told you that once you see 4, like the way we see when we look at coordinate covalent bond, you should be thinking of tetrahedral shape. So that is it for chemical combination today. See you in our next video. Thank you.